The Junkers G-38 was a truly unusual sight when it first took to the air in 1929. It was, in essence, the peak of the integral wing concept during the interwar period, at least from the perspective of practical implementation. The aircraft was created in an era when many designers believed that the future of aviation lay with blended wing machines or even full-flying wings, where passengers are placed inside the wings themselves rather than in a separate fuselage. In 1929, this idea was no longer new to Hugo Junkers. 20 years prior, he had filed a patent for a thick hollow wing suitable for creating a large passenger aircraft. As early as 1909, standard aircraft design represented what was known as a flying box, thin biplane wings reinforced by numerous wires and struts. Such a scheme worked, but was far from optimal from an aerodynamic standpoint. Junkers rejected this approach and promoted the idea of a large cantilever metal wing, which, due to its thickness and shape, provided an optimal balance of lift, drag, and practicality. The First World War allowed him to partially realize this concept. He created aircraft with an internal structural frame and all-metal wings, getting rid of unnecessary bracing wires. However, his developments were limited by military requirements. After the war, he possessed both the experience and the production capacity to create a large civilian aircraft. Now, restrictions were imposed by the Treaty of Versailles. In 1920, he began the development of the Junkers G-1, a four-engine all-metal transport aircraft. In 1921, construction of the prototype began. The outer parts of the wing and the tail section of the fuselage were assembled. However, the Allied Control Commission discovered this prototype during a factory inspection and demanded that work be stopped and the aircraft destroyed. Despite this, Junkers continued to refine new projects throughout the 1920s. He returned to a serious attempt only at the end of the decade, which ultimately led to the creation of the G-38. Together with engineer Ernst Zindel, work began in 1927 on the G-40 project, a postal seaplane for transatlantic flights. In parallel, a land-based version was developed under the designation G-38. Although the German Navy was more interested in the seaplane, Junkers himself preferred the land version, considering it more versatile, and was able to secure funding from the Ministry of Aviation. The development of the prototype took a little over 2 years. In November 1929, the aircraft with the designation D-2000 was rolled out of the factory in Dessau for its first flight. On November 6, 1929, the G-38 took to the air and at that time became the largest land-based aircraft in the world. The main feature of the machine was its enormous cantilever wing. The wingspan was 44 meters, making it even wider than that of the B-29 Superfortress. The wing construction consisted of tubular frames and struts bolted together and attached directly to the fuselage, which simplified production, maintenance, and transportation. The wing was divided into a center section, 2 intermediate sections, and 2 outer sections. The skin was made of corrugated duralumin sheets, a characteristic material for German all-metal aircraft of that time. This material not only provided strength, but also helped absorb the torsional loads acting on the wing. The wing was not only wide, but also very thick. At the point of connection with the fuselage, its height reached 1 meter and 90 centimeters. This was explained by the fact that it served not just as a lifting surface, but as a full-fledged part of the aircraft's internal space. People and equipment were located inside the wing. In the forward part of the wing next to the fuselage, passenger cabins were situated, to which a passage led. From these, a view opened through curved windows. Passengers could see not only forward, but also downward beneath the aircraft. Further in the intermediate sections of the wing were the engines. 2 Junkers L-55B-12 and 2 L-8 engines were used, which were inline 6-cylinder motors. The more powerful ones were installed closer to the center, while the less powerful ones were on the outside. The total power was 1,971 horsepower. The inner engines turned four-bladed propellers, while the outer ones turned two-bladed ones. This provided a maximum speed of about 225 kilometers per hour and a cruising speed of about 180 kilometers per hour. The engines were located inside the wing, like in a sort of engine room. They could be accessed via a service corridor passing inside the wing behind the passenger cabins. This allowed maintenance to be carried out directly in flight, a rare opportunity for aviation at that time. Behind the engines were the fuel tanks, arranged in two rows with a passage between them for inspection. Even further back were the cargo compartments for baggage and transported goods. An additional cargo compartment was also located under the fuselage, as in more traditional aircraft. The fuselage itself, like the wing, had a frame of tubular structures and metal skin. The pilots were in an elevated cockpit above the nose section. In front of them and slightly lower was the navigation room, where two passenger seats were also provided right in the nose. Behind the pilot's cockpit was the chief mechanic's station, from where the engines and fuel system were controlled. Next came the crew cabin and a room for stewards where food and drinks were prepared, with a small toilet nearby. In the rear section, additional passenger lounges and a separate smoking room were located. The level of comfort was considered very high. The aircraft was intended to compete with Zeppelin airships, which at that time were considered the gold standard for passenger transport in Germany. The control surfaces were located along the entire trailing edge of the wing and were divided into two parts. The inner sections worked as flaps, while the outer sections worked as ailerons. The tail unit had a biplane scheme with three vertical fins. This allowed for reduced drag compared to a single large rudder. All control surfaces were balanced to reduce vibrations. According to test pilots' reports, the aircraft was surprisingly easy to handle, comparable to more compact models like the Junkers F-13 and G-31. At the same time, the aircraft was heavy. The empty weight was 13 tons, and the maximum takeoff weight was 21 tons. The landing gear consisted of four large wheels arranged in pairs, with shock absorption and the ability to turn for better ground handling. After the first flight, the aircraft was purchased by the Ministry of Aviation and handed over to Lufthansa. During the trials, it attracted a great deal of attention. On November 30, 1930, the crew set several world records for speed and altitude with a load of 5 tons. After this, the aircraft was officially put into operation and began performing flights between London and Berlin. Almost immediately, it became clear that the capacity of 13 passengers was too small. The aircraft was modernized. More powerful Junkers L-8B-12 engines were installed, increasing the total power to 3,100 horsepower, and the passenger lounges were expanded to 30 seats. The modernization was completed in the summer of 1932. Lufthansa also ordered a second aircraft, which received the designation D-2500. It was originally designed based on the experience of the first and received a double-deck fuselage, as well as an increased capacity of up to 34 passengers. Both aircraft quickly gained a reputation for being extremely comfortable. Passengers could move freely during the flight, and the service was of a high standard. Despite the relatively small capacity, they became a symbol of German civil aviation. In 1933, the second aircraft was named Marshal Hindenburg. In 1934, both aircraft underwent another modernization. The engines were replaced with Jumo 4 inline 6-cylinder motors, bringing the total power to 4,023 horsepower. The aircraft received new designations. The first became G-38A, and the second became G-38E. The first aircraft did not survive 1936. It crashed during takeoff on a test flight due to incorrectly connected control cables. The pilot survived, but the aircraft was severely damaged. Theoretically, it could have been restored. However, the cost of repair was deemed unjustified, as by that time the aircraft was already starting to become obsolete. The second copy continued to perform commercial flights until the start of the Second World War. It was then repainted in military camouflage and used as a transport aircraft. It was used in particular in the campaign in Greece for the transport of troops and cargo. On May 17, 1941, the aircraft was destroyed as a result of a British air raid. A military version under the designation EK-51 was also considered, but it was never realized in Germany. At the same time, as early as 1928, Japan showed interest in the design and first proposed adapting it as a bomber. Junkers transferred the license to the Mitsubishi Company in April 1930 and sent engineers to assist in the development. As a result, the Type 92 appeared, also known as the Ki-20. Between 1933 and 1935, 6 such aircraft were built. They were equipped with 4 Jumo 204 engines, reached speeds of up to 200 kilometers per hour, and could carry up to 5 tons of bombs. For their time, they were well armed, possessing 5 machine guns and 1 20mm cannon. At the time of their appearance, these were the largest strike aircraft in Japan. However, by the height of the Second World War, they were obsolete and used mainly as transports. To this day, not one of these aircraft has been preserved. All of them were destroyed. Nevertheless, like the Italian Caproni 60, this aircraft received a kind of immortality, appearing in the Studio Ghibli film The Wind Rises.